Hi everyone, let's talk about satellite performance testing. Today we'll cover testing end-to-end satellite systems as well as individual satellite network components. I'm Cade Nelson with Apposite Technologies, and today I'm going to show you how, with the right tools, it's easy to benchmark device performance, validate QoS policies, even test without a live satellite connection, and evaluate the TCP proxy. Let's take a look at a typical satellite network. First, you might have a facility. In that facility, you might have an SD-WAN as well as a TCP proxy that connects to the VSAT with a modem and reflector. That'll be interfacing with a GEO, MEO, or LEO network, and then the downlink connects to another facility or a data center. When testing the performance of a satellite network like this, you're going to want to test not only the end-to-end system, but each individual network component on its own. Let's get into the end-to-end test scenario. A facility could have hundreds or thousands of devices, employees, or applications all communicating over the satellite. Whether you're testing a live network or a prototype network in the lab, using a traffic generator allows you to replicate the devices, users, and applications to scale. And by placing a traffic generator on both sides of the network, you can measure things like throughput, latency, jitter and loss, and validate your QoS policies. Let's start with throughput. Throughput can be a major hurdle on satellite networks because it's so inconsistent. Using a traffic generator allows you to identify bottlenecks and set your throughput expectations. You can also measure to see if you have enough bandwidth to handle your data load. And finally, you want to make sure you're getting what you paid for. Next up, let's talk latency, jitter, and loss. These impairments can be excessive on satellite networks. A traffic generator can validate whether these applications will continue to perform under these imperfect conditions. And finally, let's touch on QoS testings. It's not uncommon for a satellite network to have 3 or more priorities assigned to different types of application. To test QoS, you'll want to measure performance metrics on the application level, especially when the network becomes oversaturated. This ensures that the right traffic is given priority when the network resources become limited. By using a traffic generator to generate the expected traffic, such as video streaming, web conferencing, or voice over IP, you can determine if your SD-WAN gateway or your modem is correctly prioritizing your mission-critical traffic. In this example, we're testing over a live satellite network, but there are some downsides to that. Buying time on live satellite links can be expensive and availability can be limited. Also, with live satellites, your tests are subject to whatever conditions are that day. Since satellite network conditions are constantly changing and impacted by factors like weather or solar events, it's difficult to control and reproduce the test environment. So instead, what many organizations will do is introduce a network emulator into their lab to replace the satellite link. With Network Emulator, you can specifically control network impairments like latency, throughput, and loss to mimic the volatile nature of satellite links. You can replicate conditions like rain, storms, and snow to go from the best to the worst possible scenarios and ensure you are optimizing performances in all situations. With network emulators, you're able to reduce costs, conduct tests in a reliable and repeatable way, and produce consistent results. So we've discussed testing the end-to-end system. Now let's get into isolating the performance of a specific device on the network. There are many reasons to look at the performance of an individual network component. Perhaps you need to test a device that you are manufacturing or evaluate a new component before adding it to the network. In this instance, we'll focus on the TCP proxy. The role of this TCP proxy on the satellite network is to accelerate TCP traffic by intercepting and pre-acknowledging on behalf of the client. Using a traffic generator, you can generate a high volume of TCP queries. By setting up TCP sessions and sending data over the connections, you can measure performance benchmarks like how many simultaneous TCP connections the device can support, how fast it can set up and tear down TCP sessions, and determine if it does in fact improve performance or throughput. You're going to want to test your satellite network with and without the TCP proxy. This way you can verify the TCP proxy is actually improving the network performance as expected. In summary, the benefit of using both traffic generators and network emulators is that you can replicate the real-world conditions of a live satellite environment in your lab. This allows you to mitigate the impact of poor network quality, optimize system and device performance, and reduce costs associated with satellite testing.